Hey there, Geometry. It's Mr. Lamb coming to you with the review, the 2.1 to 2.3 review for tomorrow's quiz. I'm going to go ahead and jump right into this. And let's take a look at number one. It says classify each triangle by its sides and by its angles. So the first thing I need to think about is when I'm classifying by sides, I'm talking about equilateral if all three sides are the same, scalene if no sides are the same, and isosceles if two of the sides are the same. So I'm going to go ahead and I'm going to do A, B, and C all at the same time just by sides first. So in A, I see the little marks around on the sides. That tells me that all three sides are in fact the same. So we call that equilateral. EQUI, lateral. Equilateral triangles have three sides that are all exactly the same length. As I look at B, I see that the side lengths are 2.5, 2.5, and 4.5. So two of them are the same, and we call that isosceles. And then the last one, as I look at the three sides, I have 8.5 and 7.2, 9.1. And if none of the sides are the same, we call it scalene. So that takes care of naming it by its sides. Now I can also name a triangle by its angles. And I have really one of four things. I can have acute if all three angles are acute. I can have obtuse if two acute and one is obtuse. I can have a right if I have two acute and one right angle. And then the other one is equiangular if all three of them are the same. So as I look at 1A, all three angles are exactly the same. So we would call that equiangular. And number two, as I look at them, I see two of them are both 26 degrees, so they are both acute, and then 128 is an obtuse, so this one is obtuse. And in C, angle A is 35, which is acute, 78 is acute, 67 is acute, so they are all acute angles. That is an acute triangle. The one that we did not use there is a right. If one of them would have been 90 degrees, we could have called it a right triangle. All right, number two says find y and the length of the sides of the isosceles triangle. So I know that this is isosceles. That tells me that my left and right sides in this case are congruent. If you're wondering why those two are the congruent ones, you can actually find the congruent ones because they are across from the congruent angles. So this angle points to RT, and this angle points to RS. We'll get to that later. We'll talk about the base angles of isosceles triangles. But I take a look at these two, and since they are congruent legs, then I can set those two things equal. So 5y plus 6 is equal to 3 times 2y. Oh, sorry, minus 2. I'll go ahead and I'll distribute. So 5y plus 6. 3 times 2y is 6y. 3 times negative 2 is negative 6. I'll subtract 5y on both sides. If I take 5y away from 6y, I'll get 1y. And then to get y by itself, I have to add 6. 6 plus 6 is 12. So that gives me y is equal to 12. And question 2 says find y and the length of each one of the sides. So if I just plug 12 in, 5 times 12 plus 6. 5 times 12 is 60, plus 6 is 66. So this one over here is 66 degrees. I'm sorry, 66 units. Then I'm going to do 3 times 2 times 12 minus 2. 2 times 12 is 24. 24 minus 2 is 22. 3 times 22 is 66. So this one is 66 degrees. And the third side is 8 times y. And 8 times 12 is 96. So this one is 96 units. Those sides, just plugging 12 in back into either one of those. You can do most of that work right in a calculator if you would like. Let's take a look at number 3. Number 3 says use the diagram to find the measure of each numbered angle. Now I'm going to use the fact that exterior angles are equal to the sum of the remote interior angles. So if I want angle 1, I'm going to look at the triangle on the left. So let me show you this one here. This is what I'm looking at. I'm just looking at this triangle. So as I look at just that triangle, I see that angle 1 is an exterior angle. It will be equal to the sum of the remote interior angles. So remember, remote interior. If all 3 angles in that triangle were a TV, only 2 of them would you need a remote to change the channel. The one right next to it, it's not labeled. It's vertical to 2. It's not labeled. That is right next to it. I could reach out and just touch that TV screen and change the channel. But 58 degrees and 39 degrees, I could not touch. So if I want to talk about angle 1, the measure of angle 1, exterior angle, is equal to the sum of the remote interior. So I'll do 58 plus 39. And 58 plus 39 is 97 degrees. I'm going to put that in here now. This is 97 degrees. As I look at angle 2 and 97 are a linear pair. Well, right next to one another, they make up a straight line. So I could say that the measure of angle 2 plus 97 has to equal 180. It has to make up a straight line. Subtract 97 on both sides, and you'll get 83 degrees. And this one is 83. And then to find angle 3, I'll take a look at the triangle on the right that has angle 3, 83, and 35. If I were to add those up, measure of angle 3 plus 83 plus 35, that's a triangle, and we know that all triangles add up to 180. So I would take 180, subtract 35, subtract 83, and end up with 62 degrees. Again, you can type that stuff right into your calculator if you would like. All right, question number 4. Here is an exterior angle. This is angle BAQ right here. It's 12x minus 4. And I know this, the exterior angle is equal to the sum of the remote interior angles. So which ones are remote interior? Well, this is remote interior. This one's remote interior. They're the ones that are the farthest away. So I'm going to add those two things up. So I'm going to take 10x minus 10, and I'm going to add 30 to it. So again, remote interior angles equal to the exterior angle. The sum of the remote interior angles are equal to the exterior angle. So now I just have myself a little algebra 1 equation here. Combine like terms, 12x minus 4, 10x plus 20, when I combine the negative 10 and the 30. Subtract 10x. Add 4. Divide by 2. And I get x to be 12. Does it ask me to find the measure of the angles? Nope, it just says find x. So x is 12. For number 5, same thing. Again, I have an exterior angle, 68 degrees. Exterior angle is equal to the sum of the remote interior angles. Well, what are the remote interiors? It is this one and this one. So I add those two things together. X and X. Well, thankfully I know that X plus X is 2X. That's going to help me here. That's 2X. Divide by 2. And I get X to be 34. So each one of those angles are both 34 degrees. Number 5 is a little misleading because that ends up being an isosceles triangle, even though we can look at that picture and tell that it's not actually isosceles. Remember, do not fall victim to looking at a picture and assuming that a picture is drawn to scale, because that is not always the case. Flipping over to the back. The back of this says find X and the measure of each angle. So it's a triangle. Triangles add up to 180 degrees. So I have X plus 37, X plus 67, add those two together. And I have to add in the third angle, which is up here. It has this little red box in there, and I know that to be 90 degrees. That means it's 90. So I add that together to equal 90, set it equal to 180. Combine like terms, X plus X is 2X. 37 plus 67 plus 90 is 194. And that equals 180. Subtract 194 on both sides. Gives you negative 14. Divide by 2, and X is negative 7. Now it wants us to find the measure of each angle, so I'm just going to plug X in. This angle right up here, 90 degrees. This angle down here is negative 7 plus 37. Negative 7 plus 37 is 30 degrees. And this angle down here, negative 7 plus 67 is 60 degrees. So this is a 30 degree, 60 degree, 90 degree triangle. If I were to add those three values up, it absolutely adds up to 180. Number 7 wants us to do a proof. Alright, so over here, so we're going to do statements on one side. I'll do the reasons on the other side. And here we go. The first thing that I'm ever going to list, I'm going to list all the given information. So here we go. E is the midpoint that didn't work out well. Try this one more time. I love technology. Statements. Reasons. First one, E is the midpoint of AC and BD. So E is a midpoint for two different things. That's going to help me out a lot. I like that. And it's a vocab word, so I'm going to use definition of here in a second. We have angle B is congruent to angle D. I'm going to go ahead and mark that over here. So B is congruent to D. And also that segment AB is congruent to segment CD. All of this stuff is all given. I'll mark this as well. AB. Right here, and CD right here. Those are the same. That's all given. So remember, we talked in class, we're looking for 6 things. So I'm going to give myself a little check over here. So I need 3 sides, and I need 3 angles. That's what I'm looking for. If I can get 3 sides congruent to 3 sides and 3 angles congruent to 3 angles, I can use CPCTC. So let's take a look. So I know that B and D are congruent, so that gives me my first angle. That's good. And A, B, and C, D are the same, so that gives me a side. So I need to get 2 more sides and 2 more angles. And I want to get the sides because I know that E is a midpoint. I'm going to use the definition of midpoint. And if I were to ask you, what does it mean if something is a midpoint? Hopefully you would say it's the point that's directly in the middle of a segment. It creates 2 congruent segments on either side. And that's absolutely true. So I'm going to first look at E as being the midpoint of AC. So look over here. I want to highlight AC. There's AC. And if I were to say that E is in the middle of A and C, then that should mean that AE and EC are the same distance apart. So let's do that. AE right here and EC have to be the same because E is a midpoint. So I'll write that. AE congruent to EC. Now, my first statement says E is the midpoint of AC and of BD. So look at the triangle again, and now look at segment BD. It goes right through point E. If E is in the middle of that, then BE and ED have to be the same distance apart as well. So BE and ED are the same as well, because that is what a midpoint is. That's the definition of being a midpoint. You have to be right in the middle. So that gives me my other 2 sides. So I have all the sides that I need now. Now I need 2 more angles. And anytime I see 2 triangles that look like a bow tie, I think about bow tie triangles. Bow tie triangles always have vertical angles. So let's find the vertical angles that are congruent. So vertical angles are where the 2 lines cross. So if you look at where line BD and AC cross one another, they cross at point E. The angle over here, BEA, right here, BEA, is congruent to CED because they are vertical angles. So that's what I want to say next. I want to say angle BEA. And don't just call it angle E, because there are 4 angles at angle E, or at point E. There are 4 of them. I want BEA is congruent to CED. Now some of you might be asking, could I call angle BEA angle AEB? And yes, you can. If you wanted to put a little number in there, if you wanted to put a little number 1 in here, and a little number 2 in here, and call them angle 1 and angle 2 for your proof, you can do that. But since they didn't give us a number, I'll call it angle BEA. That's fine with me. Okay, so now I have 2 of the angles done. And if at any point you ever get to this one, where you have 2 angles in one triangle, congruent to 2 angles in another triangle, then this last one is always, 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 maybe, the third angle theorem. The third angle theorem will always allow you to say that the third angles are congruent. So in this case, the third angles are angle A is congruent to angle C. So angle A down here and angle C in the upper right. So that gives me my last piece. So now I have all my sides, I have all my angles. I can now say that my triangles are the same. So number 5 is what I was set out to prove. If you look up here in the line, it says prove that triangle ABE is congruent to triangle CDE, and the reason is C, P, C, T, C, CBC to C. Right now you're listening to the video and you're repeating it to see if you can go faster than me. I know it. All right, let's take a look at the last one. Number 8 says, given that triangle QRS is congruent to triangle GHJ, it's a whole bunch of information, and then it wants me to find x. So the first thing I'm going to do, I'm going to just draw a picture. And I'm going to draw, I don't care what they look like, I'm going to draw two triangles that look the same. And I'm going to label the first one Q, R, S. And the second one, and remember, the order matters. So wherever you put Q, put your G. And wherever you put R, put H. And wherever you put S, put J. So those are my two different triangles. And these things are congruent. So if I wanted to mark like that is congruent to that, and this one is congruent to this one, and this one is congruent to this one. All right, I could mark it if I wanted to. But it tells me that from R to S, so let me change colors here. From R to S, this is 12. And from Q to R, this is 10. So of course my picture's not drawn to scale here because my longest side is not even the longest. And Q to S is 6. And then it says from H to J is 2x minus 4. Well, if I look at the top triangle and the bottom triangle, I can see that HJ has to be the same as RS. And I can see that all the way back here, right at the beginning. I could have said HJ, that's the second and third, has to be the same as the second and third in the other one. So HJ and RS have to be the same. So I'm going to take my HJ, which is 2x minus 4. That's HJ. And I'm going to take RS, which is 12, and I'm going to set the two things equal because it tells me that the two triangles are congruent. So that means their corresponding parts are going to be congruent. Add 4 to both sides and divide by 2. X equals 8. I don't have to find what the side is, I just have to find what x is. It better be, if you plug 8 in there, 2 times 8 minus 4 better be 12, because that's what we had said from the beginning that it was going to be. Hopefully this helped you guys out as you guys are preparing for your quiz tomorrow. Quiz looks very, very similar to this review. So happy studying, and let's see how you do tomorrow. Good luck.